On this, first of all, are these two lines, A and B, are they parallel to each other?
No.
No.
CML.
Don't want that. Now, how do we know they're not parallel to each other?
No CML.
Now, can we just say because they don't have the little symbol on it? No, because we know more information now. What can we say about these angles?
They're not congruent.
They're not congruent. Should they be congruent?
Yes.
What kind of angles are they?
Alternate interior.
And this is what you have to know. You have to be able to do this. So you have to be able to say, these two angles, if these two lines were parallel, these two angles are alternate interior angles and should be congruent to each other. So here we would say no. What would our explanation be then?
Alternate interior angle should be congruent.
Alternate, and you can abbreviate, interior angles should be congruent if what?
If they form an angle.
If lines were parallel. Second part, somebody name the transversal for me. Line C. Is that all right to name it with that little lowercase letter?
Yeah.
Yeah. What's the other way that you can name lines? We can't name any of these, but what's another way? How many letters?
2.
2 letters. We'd have to know 2 different points on there, right? But they didn't tell us that way, so this time, line C. Open up your books to page 142. Page 142. Questions? Caleb over there might want you guys to ask some questions so he could get some of these answers written down, right?
Yeah.
Might be an intelligent thing to do. None of them, they're all easy. 17. Problem 17. Give me just a second to draw this picture. They say that this is R. This is line S. Then we got 2 other lines coming across through here. It's line M, line N, and they tell us that those 2 are congruent. And the directions say decide whether there is enough information to decide whether line M is parallel to line N. If so, state the theorem. Well, this is line M. It's line N. So we're just looking at those 2. With the information they give us, these 2 angles, do I want R or S as my transversal? S. All right, so I use S as my transversal, and I know these 2 angles are congruent. Did we have a theorem? What kind of angles are those 2 to each other? Vertical. Did we have a theorem that said if these vertical angles are congruent, then these 2 lines are parallel? No, these vertical angles are congruent no matter what, right? So is there enough information here? No, so we can't. We just write no, there's not enough information. Can't say that the lines are parallel to each other. Other questions? 21. And exercises 21 through 24 are line AC and line DF parallel? If so, explain your reasoning. Same idea on this problem, right? Give me a second to draw this picture. 21, they give us something that looks like this. If I just draw this without drawing all the arrows and stuff, are you guys gonna be all right? opinion, some of them might be.
Chloe.
Oh, did I mention that we're gonna take a quiz here in a minute, and you have like 10 minutes to do it, so you might wanna be paying close attention. I probably forgot to mention that, didn't I?
Sure, yesterday.
They wanna know if these lines are parallel. These two angles, they're not anything special to each other, are they? So does that mean we just stop and say, nah, they can't be parallel?
No.
No, we can find some other stuff, like this angle right here. What is it?
57.
57. About this angle right here?
123.
123. Now, are these two angles something special to each other?
They're consecutive interior.
Okay, they're the roommates, right?
Yeah.
And we said the roommates are consecutive interior.
Yeah.
What should be true about consecutive interior angles?
They have 180.
They should add up to 180. Do they add up to 180?
Yep.
Yeah. So if those two add up to 180, then what can we say about these two lines?
They are.
They gotta be parallel to each other. So yes, are parallel, and our reason is because, give me a reason.
They add up to 180.
What adds up to 180?
Consecutive interior.
Consecutive interior angles add up to 180, or you could have just said consecutive interior angles are what to each other?
Supplementary.
Supplementary. You could have just put supplementary in there, maybe made it a little shorter on yourself. Gotta be able to give a reason. You gotta say, our statement is, yeah, they're parallel. What's our reason? Consecutive interior angles are supplementary to each other. Gotta be able to give those reasons on all this. Other questions? 34. Problem 34 is probably the last one, and then we're going to take this quiz. Problem 34. It's a 2-column proof. This time I'm just going to put G for given. Angle 1 is supplementary to angle 3. And we're trying to prove that M is parallel to N. They give us a picture, it looks like this. Watch on these 2-column proofs. I know none of you really need to watch on them because everybody understands them completely. They tell us angle 1 is supplementary to angle 3. So this angle is supplementary to that one. It means that they add up to what? 180? Tell me something else in this picture that we know.
1, 2.
What about?
The vertical.
So angle 1 is congruent to angle 2, and our reason is because vertical angles are congruent, always. Alright, so we're probably going to use that in our proof somewhere. Well, if angle 1 is supplementary to angle 3, that was given to us, right? And angle 1 is the same as angle 2. Can we put angle 2 right there in place of angle 1?
Yes.
Yeah. So then that's going to tell us that angle 2 is supplementary to angle 3. Well, you guys just told me on that last problem, if those two are supplementary, what can we say about those two lines? They're parallel. And that same reason that we wrote down, anybody remember the reason we wrote down a second ago?
Consecutive interior angles add up to 180.
Consecutive interior angles are supplementary, then these two lines must be parallel. So we should be on, Evan's never going to say lines are congruent again, right?
Yep.
Because you can't measure lines, so they can't be congruent. Statements, reasons. What's our first statement going to be? Angle 1 supplementary to angle 3. How do we know that? Better pay attention. Now that was all the given information. Where do we go next?
Angle 1 is congruent to angle 2.
Angle 1 was congruent to angle 2. How did we know that?
Vertical angles are congruent.
And a lot of people are just writing vertical angles here. Don't do that. You got to put vertical angles are congruent for those people like Kenneth who don't know. Yeah, they're vertical angles, but what do we know about vertical angles? They have to be congruent. Now what can we say?
Two and 3 are supplementary.
Okay, we can plug in angle 2 right here. Angle 2 is supplementary to angle 3. What did we use there to go from these two statements to this new statement? Substitution. That's all you got to write over here. Substitution property. Substitution property. Number 4. Is that what we were trying to prove was number 3?
No, it's angle 1 is supplementary to angle 3.
That's what we were given. What are we trying to prove?
M is parallel to N.
Can we now say that?
Yep.
If these two are supplementary, if these two right here are supplementary, how do we know that those two lines are parallel then?
They have 20.
So, and we gotta write it out.
Supplementary.
You can't just put add up to 180 or supplementary. You gotta put consecutive interior angles, supplementary. Then what's that tell us? Lines parallel. Then the lines have to be parallel. If the consecutive interior angles are supplementary, then we know that the lines are parallel. You got to have that whole thing. If you just put part of that, then it's not the right reason. It doesn't tell whoever looks at it next what you were doing. All right, on this, you need to get out a clean sheet of paper. On this quiz, it's in the book, so keep your book open. It's on page 146. It's up here, Kenneth. What's that say? 11:12. Add 10 minutes to that. 22. That's what you have from this moment right now. So if you sat there and screw around, you will not get finished. But 11:22, everybody's going to lay their quiz up here. The other thing I'm going to tell you, you can work with one partner. So get with your partner and get started right now. Don't mess around. 11:12 or 11:22 is when we're going to be done. On the quiz, problem number 1 is one line. You should be looking in your book. Curtis, I'm done talking over you. Shut up.
You're recording.
I don't care. Then you guys should shut up, right? Problem number 1. It says line EF, and they want something, another line that's parallel to it. Give me a line that's parallel to EF. HG.
Yeah.
There's several of them, right? All you needed was one. All I wanted was one of the lines. Number 2, give me a line that's perpendicular to EF.
BF.
BF, FG. All right, several of them. Number 3, give me a line that's skewed to EF.
CD. I don't know.
Skew, what's skew mean again?
It's like this.
All right, so the ones that look like something like this. All right?
It'd be like this.
So EF, looking at EF there. Give me a line,
CD.
CD. Does everybody agree with that?
What?
CD, what's true about CD and EF? They're parallel to each other, aren't
One's
they?
over here, one's over here. Told you, Evan Short.
Say it again. AD. Shh. Bree said AD. They look like this. Is that true? Yeah. Number 4, give me a plane parallel to ADE. How many lines, or I'm sorry, how many points do you need, how many letters to name a plane?
3.
So name me a plane that's parallel to ADE. BC, G, what'd you say? CBF, would that work also? Yeah. Any of those, there's 4 of them back here, and you could have picked any 3 of them to name it. Number 5, looking at that picture, name me a pair of consecutive interior angles.
3 and 5.
3 and 5, that'd work. Name me a pair of alternate interior angles.
4 and 5.
5 and 4. Name me a pair of corresponding angles.
1 and 5.
7 and 3, 1 and 5, both those would work. Remember, corresponding angles are the ones, what do you do with the lines?
Yep.
Smash them together and the angles should lay over top of each other. Number 8, alternate exterior angles.
1 and 8, 2 and 7.
1 and 8, 2 and 7. Number 9, on number 9. Problem 9 looks something like this. Should we be able to find all the angles on number 9?
Yes.
Now I'm just going to draw the picture real quick here. They only want us to find angle 1 and angle 2. Somebody help me out. How would we find the measure of angle 1? Subtract it from 180. What'd you get? 42. Everybody agree with that?
Yep.
If this angle's 42 degrees, what can you tell me about this angle and angle 2?
42 degrees because they're alternate exterior.
They're alternate exterior, so the measure of angle 2 should also be 42 degrees. So those are your two answers you should have had for number 9. Number 12. Wow, we just got done doing this problem, didn't we?
Yeah.
We had this. We know that this angle is 69 degrees. This one's 111 degrees. And they want to know, are these two lines parallel to each other?
Consecutive interior.
So we put, yes, they are parallel. How come?
Because they are consecutive.
Because they have to 180.
Consecutive interior angles
Add up.
supplementary. Then what's true?
The
They-
lines are parallel.
Lines are parallel. You gotta write these out. I think I just said that right before the quiz, right? So that'd be worth 2 points. The yes worth 1 point. If you wrote that theorem out,
Is there
second point.
Yes, consecutive exterior.
no, because they can't be consecutive if they can't be roommates if they're both on the outsides, right?
Oh, I agree.
Now, to tell you this, old book that I taught out of didn't call these consecutive interior. They actually called them same side interior. And then if we looked at these two angles right here, could you call those same side exterior?
We-
Yeah, are they on the same side of the transversal? So that always made more sense to me, but all the new books say consecutive and they don't worry about the exterior ones. So same side interior angles, and I always abbreviated it SSI, same side interior, had to be supplementary. Guess what was true about same side exterior angles? They have to be supplementary also. All right, go ahead and start copying this down. This is your set of notes for today.
Yeah.
I know what else.
That's right, using it.
So copy this, perpendicular lines. Be able to find the distance from a point to a line. We're going to talk about that just here in just a minute. This is very, very important. And not only is it very important, but it's very difficult for me to explain. So you've got to make sure that you're listening closely. So even when my friend's sitting right here that likes to lay her head down all the time, she might want to make sure that she perks up a little bit for this, because I'm telling you it's going to be difficult. Distance from a point to a line, we're also going to prove and use theorems about. What's that symbol mean? Perpendicular. What's perpendicular tell you?
400 degrees, right?
Right angles, and then right angles tells you 90 degrees. Be able to solve real life problems using perpendicular lines.
I got it.
All right, draw this. Distance from a point to a line. Again, very important, sort of difficult. If we're looking for the distance from a point to a line, it's always going to be the length of the perpendicular segment from the point to the line. So in other words, if I'm trying to walk from this point to line AB. And we want to know the distance from that point to line AB. Do I want to walk from Q out here to A somewhere? Why not? It's longer. If we're talking about the distance from Dallas to New York, we want the shortest path, right? We're not going to say, okay, the distance is 6,250 miles because we went through Fort Lauderdale, Florida, then we went to Raleigh, North Carolina, then we went to Albany, New York, and then we went to New York, right?
You were going from there to there, okay.
So if we want a distance, we want the shortest path. Anybody have any idea what would the shortest path be from Q to this line? Come up and draw it for us. Austin's going to draw it for us here.
Don't know if it's right. I'm just gonna draw it.
So we'll see here in a minute because I have a line that's hidden right now that's on here that's going to be the shortest path. When it comes straight to it, what should happen right here with Austin's line or with Austin's segment? Should form a right angle. That's going to be the shortest path. When you have a path from a point to a line, it's always going to be that segment that's perpendicular to the line. So let's see if Austin was right if I put my line in there. It's pretty close, wasn't it? Distance formula. As soon as we start talking about distance, you need to remember this distance formula. Does everybody remember it? We're going to start using it again. If you're using distance formula, what do you have to use the distance formula?
Two X and Y.
Two ordered pairs, right? An X and a Y, 1 point, another X and a Y. So you got to be given 2 points. So we're going to be on a graph. You're going to be given some point maybe like here, point A, and some point up here, point B. And we want to find that distance, that length of that segment. And we use the distance formula to do that. Don't make the distance formula harder than it is. Do these little 2's and 1's mean anything? Those don't. How about those two? Yeah, those mean square your answer. Don't make it harder than it is. You're just finding that length. You're going to plug the X's in here. This first part, you're going to plug the Y's in the second part. The biggest problem that most people have with the distance formula is they get their X's and Y's switched up. Right? They'll put like these two numbers in the first set of parentheses and these two in the second set of parentheses. And it doesn't work that way. You got to put your X's here and here and your Y's here and here. That makes sense, right, Caleb? So let's just give me 2 points. 3, 1. That's one ordered pair. Give me another one. 1, 2. Let's make one of them. Let's make it a -2, just to have a negative thrown in there. I'm going to start to write this distance formula. What's my 2x coordinates this time? So 3 minus 1 squared. That's an x. That's an x. Plus 1 minus a -2. What's going to happen there with that 1 minus a -2? Change to positive. Those are our two y's. Just make sure you don't get them confused. Don't turn them around. Alright, what I need you to do, go up front here. You're going to grab, as soon as I get these quizzes out of the way. You're going to grab a ruler, you're going to grab a compass, and you're going to grab a worksheet. Go ahead. Ruler, compass, and a worksheet.
That's it.
And come up here and sharpen it with this little sharpener.
They told me that.
Been telling you that all year long.
Where?
Make sure with your compass, and I know I said this last time, so I probably don't need to repeat it because Austin's a smart young man. I just got down, or I just got done
I know.
tightening them with a little screwdriver, and it's a pain in the butt to go through and tighten them all. So don't sit here and yank on them.
What do you think he's telling us to do right now? Sit up and yank on it.
All right, what you're gonna do, and I'm gonna give you about 4 minutes. 4 minutes, you're gonna follow these rules up here, or these steps that I'm getting ready to put up here, all right? And then we will go over it together. But first, and I don't want Curtis to sit here and do nothing, just staring at his paper. I want him to try. Everybody understands that, right? Now, to make it easier, maybe something I ought to say, you might want to grab, maybe like I'm looking at Curtis is here, put a piece of scrap paper underneath it so that, or if you do it on the binder or something else, because then that'll help your compass stick to it a little better. If it's on the hardwood desk, then the compass won't hold on very well. Does that make sense? So what you're going to do, you're going to follow these steps. Try before you ask.
A half circle.
It explains it, Chloe, so
A half circle.
yeah, something like that.
I don't know if I-
Just do what it says. Half circles, half of a circle.
And how wide? How wide is
It doesn't really matter as long as it, if this is my line, as long as it goes through the line. Look, I don't want to make it so wide that one end hits the line, Caleb, and the other one comes way out here. Alright, so I want it to hit the line. I forgot to put point P on mine, didn't I? I swear I put point P on there. Point P's on yours, right?
What are you doing?
Where's point P at on there at the top?
Are we going right or left?
Doesn't matter. Doesn't matter what them.
Not really. I swear I put a point P on there and it disappeared on me.
Compass.
Looks alright. Hit the line twice. Read what the next one says. Again, these constructions, what's a construction? What's the word construction mean? Nobody knows?
What'd you say?
Work.
Build, make.
This is what Chloe's not gonna
Well,
try.
intersections point A. Maybe, but I.
So where your arc that you just made, it intersected the line, right? We're talking. So point, so look, it came through the line right here, put a point right there, and call that A. It came through over here, point there, call that B. Yeah, you guys think these harder than they are.
They are hard.
Now read directions and follow.
I'm following.
So we have all this. Drew in that line. Now my line looks horrible, it doesn't work. The same as yours because I just drew mine freehand. That's why you're making a construction. You're actually doing something using some kind of tools, and I'm not, I'm just drawing. They ask us, what is the measure of angle, or of the angles? So we're looking at these angles right here. Anybody have a guess on your paper there? What's the measure of those angles? They're 90 degrees. So what did we just draw? We had a line,
Right angle.
we had a point here, and we drew a segment or a line that went through there that was perpendicular. Sorry, just quit working. That was perpendicular to perpendicular to our original line. All those should have been right angles. Is it important maybe at some point to be able to know that this line is perpendicular to this line?
Yep.
Yeah, when they built this school, did they need to know that this wall right here came to this wall and made a right angle? Yeah, probably. If they didn't know that, and let's say they start building on this end, and that angle right there wasn't a right angle, by the time they get to the other end of the school, is it going to work out very well? No, even if it's off just an inch here, by the time you get to the other end of the school, it's probably going to be off about 6 inches. Then your two walls are going to go like this, and you're going to have a big gap there. All right? So you got to be able to decide that these things are perpendicular. You got to be able to construct something that's perpendicular to something else. Not only that, what we just said a second ago, if that's perpendicular, and we're looking for the distance from P to this line, then that right there has got to be the shortest path because it's perpendicular. That's got to be your shortest path. All right, try this next one on the bottom part. Less trouble on this one. Try this one. Read it. Now you're on the other one, on the segment instead of the line this time. All right, so again, a perpendicular bisector is perpendicular to the segment. Makes right angles with the segment. Maybe that'd help you to put right angle so you can remember what perpendicular means. Makes right angles with the segment. And what's bisect mean again?
Splits it in two glass.
Two congruent segments. Splits it into two congruent segments. Perpendicular bisector. Alright, these three theorems, go ahead and write these down. Draw the pictures with them. We're going to talk about those. Again, do I ever want to hear you say theorem 3.10 again?
No.
No, all I care about is that you know this part. So if you want to just put an asterisk here, but beside each one, instead of writing out theorem 3.11 or 3.12, then you do whatever is best for you. Somebody yesterday told me, well, I'd like to have the theorem 3.10 written down there because it helps me. I said, that's fine. Just don't give me that as an answer.
You really don't like typing these. So that you put the and symbol instead of A and B.
Usually I do write out the word and because it's easier for me to find A, N, and D than it is to hit shift and then that other button. This time I don't know why. My finger must have already been close to the shift button or something. So I. Okay, well, that's something else we need to do is get the notes off somebody or something. Remember, binder should be an easy grade, right? So we got 3 sets of notes right now. I'm not sure how many you've had. Maybe I know you missed at least one. Second one, so you're missing that one. So just get them off somebody and copy them. That way your binder's caught back up. The intervention with Wyatt, get them off him.
Hey, I was so funny. That was just so funny with it.
On the first one, it says, if two angles are a linear pair. What's it mean if two angles are a linear pair?
They're congruent and they're one.
They make if they're just a linear pair, they make a line. They make a line. So if we have two angles and they make a line, which these two angles, angle 1 here and angle 2, do, and we know that they are congruent. Remember, these arcs tell us that those are the same, they're congruent. Well, the only way this will work out for those two to add up to 180, being a linear pair, and be congruent to each other is if both of them have a measure of what?
180.
If both of them have a measure each, 90 each. So each one has to be a right angle. So if you're given a picture, if I give you a line, and I do this, and I tell you these two angles are congruent to each other, then we know that those two angles have to be right angles. There's no other way mathematically that it could be anything else. The next one, if a line is perpendicular, what's perpendicular mean again? Forms what? Right angles. So if a line is perpendicular to one pair of the two parallel lines. So we got this line. What's that line called? You guys have been wanting to say this word all day. Transversal. So we got this transversal, and it's perpendicular, forms a right angle with that line. These two lines are parallel. What has to be true about these angles up here?
Parallel too.
Not parallel. They got to be 90 also. They got to be perpendicular also. So if I hold up these two parallel lines, and then we have another line that's perpendicular to one of them. So I tell you my elbow is making a right angle with the bottom line. Then what do you know about my fist with the top line? It's got to make right angles up there also. That's all it's saying. All right? So if these two lines are parallel and there's a line perpendicular to one of them, then it's got to be perpendicular to the other. Now, this theorem, not really useful because if you knew this one right here was 90 degrees, could you find all these other angles in this picture? Yeah. So if we know that's 90, then this one over here that's an alternate interior has got to be what? 90. This one over here that's vertical to that's got to be 90, and we could find it all that way, even if you don't remember this theorem. The last one. If I have my two lines, and I tell you my fist makes a right angle with the top line, my elbow makes a right angle with the bottom line, then guess what has to be true about these two lines? They have to be parallel to each other. So it's just sort of the converse of this one. Not really the converse, but sort of just switches it around. All right, write this down. We're going to do this two-column proof. This is going to be in your notes, and we're going to be done for the day. Curtis, this you need to get out and write down. Because you wrote it down, but you couldn't have got it worked out. So write down this problem. Kenneth wants to write it down because he loves these two-column proofs so much that. Just kidding, Kenneth. The reason you want to write it down is so you have an example right there to look at, right? When I have you do them, so that we don't have the same crap that we had on the last test where a lot of people just left them completely blank and got no points.
Do we just put like numbers like 1, 2, 3?
I said a lot of people. I didn't say Kenneth, did I? Yeah, put those numbers in there and put the letters on the A's.
I was talking about like if we put a 3 stamp, it'd be like 1. Yeah, then right.
Get that. Okay. You know where?
We can just
Where is it?
Can you number these? Like,
Steps?
no, like you number the angles.
Yeah.
That's a terrible way of numbering. One you did this way, and the other one you did that way, and it's like there should be like, it should be 1, 2, 3, 4, not 1, 2, 4, 3, and
I'm just ready for Friday.
Why not 1, 2, 3, 4 going around in a circle?
That's not how people read.
Oh, that's how I did it.
That's what-
Yes. Yes.
Thank God.
I'll send him down. Make sure you get the assignment off somebody. Shh. All right, looking at this.
Now I have my computer marked.
make sure you get the assignment. We know that line H is parallel to line K, so come over here to your diagram
Yep.
and put the arrows on it.
Yep.
Gotta start doing this stuff. You gotta be able to label these pictures and do all the stuff that needs to be done. They tell us that line J is perpendicular to line H. This is line J, it's perpendicular to line H. So tell me something we know then. If this is perpendicular to line H, it has to be a right angle. What angle has to be a right angle? Angle 2, angle 1. Doesn't matter really which one we pick, right? Just angle 2. See you later. So we know that that's a right angle. If that's a right angle, that's all the given information that we have. What else can we say?
H and K are parallel. We already said that.
We already got that. We got all J and K are perpendicular. How come? All right, we had a theorem that just said that, right? Now we're gonna not use that theorem. We're gonna try to do something else.
Do you get credit for just saying J shows us the line?
No. Just like you wouldn't get credit for saying 5 is a number.
So 6 and 6.
All right. So if we got angle 2 here, we said angle 2 is a right angle. Right? We just said that because of the perpendicular. What other angle has to be a right angle?
1, 3.
Angle 1, angle 3.
5, 6, 7.
All right, let's do one that helps us get to over to here. What other angle down here? And give me a reason. Angle 8. What kind of angles are 2 and 8?
Alternate.
Alternate exterior. Didn't we have a theorem last time that said if alternate exterior angles are congruent,
And the lines.
then the lines are parallel, right? Well, I'm sorry. Let's go back. We don't want to say that one. We want to say, because we already know the lines are parallel, don't we? If the lines are parallel, what do we know about alternate exterior angles?
The angles are congruent.
The angles are congruent. So what's angle 8 got to be? 90 degrees. It's got to be a right angle. Is that what we were trying to prove? Do we now know that J is perpendicular to K?
Yeah.
So we should be able to do this 2-column proof. Let's see if we can. Statements, reasons. What's our first statement going to be?
H is parallel to K.
How did we know that?
It's good.
That was given to us.
Then you can put
Now, do we want to put the other given in that same statement?
no.
No.
You can put angle 2 and angle 8 or alternate exterior.
Nah, you're jumping way, way ahead. You skipped a whole bunch. Now, what do we need to say next? J is perpendicular to H. How did we know that? Given. Now, we could use the theorem that we just went over right now and just do like 2 more steps and be done. But we're going to actually go without. It's like we're proving the theorem is true, is what we're doing. We're proving this theorem. So we got J is perpendicular to H. Now, if you know that these two are parallel to each other, that's perpendicular. What did we say we knew about angle 2?
Angle 2 is the right angle.
So let's write that. Angle 2 is a right angle. How'd you know that angle 2 was a right angle? What told us that?
Lines. J is perpendicular to H.
Okay, so we put perpendicular lines. This is what you write every time when you use that symbol. Perpendicular lines form what?
Right angle.
Right angles. Right angles.
You say angle 8 for angle 2.
Now, well, we actually need to say something else. What do we know about angle 2 and angle 8?
And the exterior.
They're alternate exterior angles. So, what's that tell us about them if they're alternate exterior?
They're congruent.
So angle 2 is congruent to angle 8. And our reason is if parallel lines, this is the theorems from a few days ago, then alternate exterior angles are what to each other?
Congruent.
Congruent. Are we done?
No. Yeah, you have to prove.
Now, what are we gonna say about angle 8?
Angle 8's for an angle.
Angle 8 is a right angle. Angle 8 is a right angle. How do we know that?
Perpendicular lines form right angles.
Now be careful, because we don't know that these two lines down here are perpendicular yet. How, from 3 and 4 here, how did you know that angle 8 was a right angle also?
Because those are next here.
Sorta, we already
The
used
lines are
that.
parallel.
What did we say right here? Angle 2 is a
Right angle.
right angle. We know angle 2 is congruent to angle 8,
So,
so angle 8 has to be a
right angle.
right angle for those two to be congruent, right?
Yeah.
Give me a reason. What did we sort of use there?
Substitution.
You could just put substitution, I would probably accept that. Probably not the greatest thing, but we sort of use substitution there. We just took this up here and we said angle 2 and angle 8 are the same.
Yeah.
Angle 2 is a right angle, so we could take out angle 2 and stick angle 8 in its place. Now, once you know angle 8 is a right angle, now what can you tell me about line J and line K? Line J is perpendicular to line K, and our reason is going to be what? Is it going to be the same as number 3 up here? It's backwards of that, right? If you have right angles, then we know that the lines are perpendicular. So if right angles, then lines perpendicular. It's the converse of the definition of perpendicular.
Did you use reflexive?
Reflexive says what?
Equals like.
Equals itself.
And 2 and 8 are the same thing.
No, they're the same thing, but are they, that's like saying Evan and Hunter are the same thing. But if I wanted to use reflexive property on Evan, can I say Evan equals Hunter? No, I gotta say Evan equals Evan. Alright, go ahead and copy this down.
We ever test that?
This is your assignment? Yeah, we'll probably pass them out here in a second. Or you might change your mind here in a minute. Do not lose these. These are the only 2 hall passes you get for this 9 weeks.
What if, so like, if we don't use these in these 2 weeks, can we use them in the next 2 weeks?
Next 9 weeks?
Yeah.
I might do that. So if you can hang on to them, yeah, probably.
What if we don't use them?
You don't use them, I don't know, maybe at the end of the year, if you still have all of them collected up, maybe I'll give you some points or something.
Points.
What do you want?
I want, yeah, don't you?
I don't want
that's what
points. I want like
points.
some prize.
She wants like candy, but I want
Some
points.
extra
iPhone
credit.
7.
is on failing.
iPhone
Uh,
7.
You can have them back.
See, that's what I'm saying. So, no, I don't want them back. I want you to be able to hang on to them.
That's a lot.
iPhone 7, that's
Bribing,
prize.
bribing kids not to use the